Okay, so today we're going to talk about the Pythagorean Theorem. That's a squared plus b squared equals c squared. Hopefully you're all pretty familiar with it. A squared and b squared represent the legs of a right triangle, and c squared is the hypotenuse. Okay? So actually, this is a real life example. My mom is in a wheelchair, and we had to build a ramp so that we could get her wheelchair up to my house. And so the numbers aren't exactly right, but I measured the height of the steps, and it was 20 feet, 20 inches. And my ramp, like there's a given angle, like you can't have a ramp that's too steep because you couldn't push it up the ramp. Like if the ramp went like that, you couldn't push the wheelchair up, like you'd fall backwards. Or, if it's too long or the angle here is too flat, then it goes way out too far into the street. So there's like laws about how high this angle has to be here. So it ends up that this ramp part is 19 feet, and I want to find out how long it is, because I have this tree over here, and I just need to make sure that the ramp isn't going to run into the tree. All right, so these are the legs. I know because they are coming together to make the right angle. So let's just call this A and this B. Doesn't really matter. You could switch them if you want. So I get 20 squared plus, and 19 is in feet. So I have to be careful. I have to do 19 times 12 to get this into inches as well. Okay, so 19 feet is 228 inches. So it's 20 squared plus b squared equals 228 squared. So that's 400 plus b squared equals 51,984. Okay, subtract 400 from both sides, and I get b squared is equal to 51,584. Okay, so if b squared is equal to that, to undo it, you take the square root of both sides. So I take the square root of 51,584, and I get 227. So b is 227.12 inches. So I divide that by 12 to turn it into feet, and that's 18.9 feet. Okay? All right, so to use the Pythagorean Theorem, hopefully it's just a plug and chug kind of thing. You label the legs A and B, the hypotenuse is C, and you just do a squared plus b squared equals c squared. All right, the converse is also true. If a squared plus b squared equals c squared, then it's a right triangle. So if to test if these are right triangles, I know that the hypotenuse has to be the longest side, and the square root of 52 is 7.2. So I know this is the longest side. So I know that A and B must be 4 and 6. So 4 squared plus 6 squared should equal the square root of 52 squared. 4 squared is 16. 6 squared is 36. And square root of 52 squared is just 52. So that's 52 equals 52. So this is a right triangle. Okay? This one, here is my longest side. So it would be 7 squared plus 12 squared equals 13 squared. So 49 plus 140 169. That's the 18093, and 193 does not equal 169, so this is not a right triangle. Okay? And we can use, there's one other really handy thing to use with Pythagorean theorem, and that is it can tell you also if it's an acute or an obtuse triangle. So if you look at here, if a squared plus b squared, we already did this. If a squared plus b squared equals c squared, then we know it's a right triangle. Okay? But if a squared plus b squared is greater than c squared, then it's acute. And I know it seems a little bit counterintuitive, but because it's greater than, but that means it's acute. But if you think about it, that means that the length of the legs is greater than the square of the hypotenuse. So that must mean that the hypotenuse isn't that long. So that means it's acute because those sides can come in more. And if a squared plus b squared is less than c squared, then the triangle's obtuse. Okay, same thing. If the two sides together don't quite make up the hypotenuse, that must mean the hypotenuse is really long, so that means the angle must be opened really wide. Okay, so if I'm trying to test to see if what kind of triangles these are, I know the longest side has to be C, and then it doesn't really matter which other two I pick. So I do 8 squared plus 11 squared, and then I don't know if it's going to be greater than, less than, or equal to 13 squared. So that's 64 plus 121, and then I don't know again, is 169. That's 185 and 169. So I know that it's greater than. So if it's greater than, that must mean that this is an acute triangle. Okay? Then this one, since 15.6 is the longest side, that's C. So it's 5.8 squared plus 9.3 squared. And then I don't know if it's going to be greater than, less than, or equal to 15.6 squared. Right? Okay, so when I square those, I get 33.6 plus 86.5 equals 243.4. If I add these two together, that gives me 120, and that is less than 243. So that must mean this is an obtuse triangle. Okay, and then again, 15 is the larger, so 9 squared plus 11 squared, well, we don't know yet. I want to make an equal sign there. We don't know, equals 15 squared. So that's 81 plus 121. We don't know, and it's 225. Okay, and then I add, so that's 202, and that's less than, so this is an obtuse triangle as well. Okay, so equal to, it's a right triangle, greater than, it's an acute triangle, and less than, it's an obtuse triangle. Okay, and then we have these, what we call Pythagorean triples. It's right here, but I don't know if you can read it. These triples is a set of 3 non-zero whole numbers. So they're going to be positive, they're going to not be a fraction or decimal, and they work together so that a squared plus b squared equals c squared. And so I would memorize these 4, okay? And just because when you're doing problems like these here, if you recognize that it's a Pythagorean triple, you don't even have to do the math. You can just say, oh, right triangle, that's a Pythagorean triple. A squared plus B squared, if this is A, this is B, it always equals C squared in these sets of numbers. And the multiples of these numbers can work. So like it could be 3, 4, 5. It could also be 6, 8, 10, or 15, 20, 25. All the multiples of those numbers work as well. Okay, and remember, in the 3, 4, 5, 5 has to be C. So if I look at this, I've got A of 8 and a B of 10. I notice right away that they're even, so I'm going to divide by 2 and get 4 and 5. Well, that kind of looks like a Pythagorean triple because they've got 4 and 5 here, but I know 5 has to be the hypotenuse, and the hypotenuse is blank. So this is not a Pythagorean triple. I would have to just go and do the Pythagorean theorem to find out what that is. Okay? This one is 1 and 2.4. So obviously this is a decimal, so it's not going to be a Pythagorean triple. Okay, this one, again, these are even, so I'm going to divide by 2 and get 8 and 17. I look over here and I say, ooh, 8 and 17. 17 is the hypotenuse. I've got 8, so that must mean this is 15. Okay, that's how you would use a Pythagorean triple. All right, and we'll play this game tomorrow. Just a quick review of simplifying radicals. I know we did this already at the beginning of the year, but I just want to remind you, you take, so when we're solving like the Pythagorean theorem and you get, I don't know, if you get square root of 50 as your or if you get 50 as your c squared, so you take the square root and you want to reduce it, if it asks you for the exact answer, you would take 50 and break it down into its component parts. So 5 and 10, 2 and 5. And any pairs can come out of the radical sign. So the 5 can come out, the 2 doesn't have a date, so it has to stay in. So the reduced form of the square root of 50 is 5 square root of 2. 300 would be 3 and 100, which would be 10 and 10. So that has a partner, so 10 can come out, 3 has to stay in. So if it's asking you for an exact answer, you would give them the reduced form of the radical. If it just asks you for an estimate, then you can just plug square root of 50 into your calculator and write the decimal. So if I did square root of 50, it would be 7.07. So the estimate would be 7.07. The actual would be 5 square root of 2.